right, so on this one yesterday, talking about whether or not it was continuous. So we know to the 2/3 power, that means we could square it and then take the cube root. I can put any real number in and square it, and I get a real number out. I can put any real number in and take the cube root, whether it's positive or negative. So that's one way we know it's continuous. If it's not continuous, there'd be a jump discontinuity, which would mean it was piecewise. It's not piecewise. It could also have a hole, but if it has a hole or a vertical asymptote, then that means it's a rational function, because the only thing that happens is when zero's in the denominator, right? And so this is not a rational function. It's also not a polynomial, but it's not a rational function, so I don't have any reason to get a hole. I don't have any reason to get a vertical asymptote, and I can put in all real numbers, so I am good to go. So that's basically how we know. The whole rational, I was like, well, how do you know? Well, it has to be irrational for you to get the vertical asymptote. That just didn't come to my brain yesterday when we were talking about it. So that's how we know. Just kind of think through what would happen if I put numbers in there. All right, so now we are switching gears a little bit, still talking about MVT, but we're going to compare it to IVT. So, and this is going on 51. So intermediate value theorem, that is our IVT. Remember the intermediate in the middle, if something is between something else. Mean value theorem, that's when we're talking about an average rate of change type of situation. Okay, so we just did MVT yesterday. So remind me, what conditions have to be met for us to be able to use MVT? Continuous and differentiable, okay? Continuous and differentiable. Do you remember what the conditions had to be for IVT? Continuous was the only one that had to be true, okay? If it's differentiable, that's fine, but all we cared about was, is it continuous, okay? So what to look for, okay? And so we are going to kind of split this space because it's not big enough, and I want to write some things in there. If you see questions like, is there a time, or can you guarantee, I never spell guarantee right, G-U-A. I think that's right. I usually spell it so bad, spell check won't get it right. Is that right? G-A-R? I don't know. I'm pretty sure there's 2 E's. I don't know. You can write it however you want. It's guarantee. You spell it however you want. How do you spell it? This is right? I'm right? Thank you very much. Oh, in your face. Look at me spelling things right. I know, but it looks wrong. That's why I usually, maybe it probably is. But when I type it, I don't know. It seems like people should mess this up a lot. Like it should know. I don't. Whatever. I guess it's my bad handwriting. All right, but that's how you spell it. Must there be, okay, must there be, ... So those kinds of things. Is there time? Can you guarantee? Must there be? Those types of questions work for both of them, actually. Okay? So that what that tells you is that is a theorem type of question. If we're going to guarantee and that sort of thing, then it's one of your MVT, IVT, it gets you thinking maybe it's this one. The way that you know for sure then to distinguish those two is that the IVT, you'll have conclusions, I do know how to spell that one, about values in the table that may be missing. Okay? Conclusions about values in the table. So we see some other values, there's something missing, and we want to talk about, could there be a time, is there a time when V of t equals 3 or 0 or something like that? It's missing in the table, and can we guarantee that it's there? That's what IVT is, in between, the intermediate value theorem. For MVT, we are looking for conclusions about rate of change of the given function. Okay, so these questions sound very much alike, okay, because they're using the same types of questions. That's why written there in pink, you can have the same types of things, and those, it's not limited to that, but you're looking for something, that kind of means that. It's what the conclusion you're drawing, that's how it determines which one it is. So when we look at these two examples, the tables are identical. They even start off the same, right? It goes all the way to be the same until you get to this last line. The only thing that's different in these two questions is this and this. That's the only thing that's different in the two questions, okay? You see the difference there? So for this one, the table is talking about the velocity. And it's asking me, is there a time where the velocity is going to equal -1? Well, that's -1 is not on this table, so it's missing from there. That's how I know that this is IVT. Not just that it's in that column, right? Because I'm always going to be in a column. Here, my table is about velocity. It's asking me about acceleration, which is the rate of change of the information given. And that's how I know this one is MVT. Okay, does that make sense to you? Okay. So when we look at our work, what we're going to have to put here, we have to have what conditions have to be met for IVT. Okay, it has to be continuous. Is this function continuous? And if so, how do you know? Okay. Is this continuous? Is V of t continuous? If so, how do you know? Because it's differentiable. Remember, every time we see differentiable and I say, hey, if it's differentiable, what else do we know? It's continuous, okay? So I can say V is continuous on, okay? Now, this is my interval from 0 to 9. So it's continuous on 0 to 9, and you have to be continuous on a closed interval, okay? And then that's a true statement, and that's all we only have to state continuity, but the reason we know it is because it's differentiable. Does that make sense? That's why we have to state it. So because V is differentiable on the open interval from 0 to 9. So you're differentiable on an open interval, you're continuous on a closed interval. Because continuity has to include the endpoints and differentiability doesn't. And that's why. But once when we start looking at the second derivatives more and talking about more about what that looks like graphically, we will cover that. Right now, go with because I said so, but we'll cover it. It's a good question, though. All right, so over here, and we can basically say the same thing. Over here, it has to be continuous and differentiable. So if it said continuous and differentiable, then we can't, then we could just say, yes, that's happening, but we basically can say the same thing. V is continuous on 0 to 9 because V is differentiable on 0 to 9. Okay. So even though on this one, I'll say this once again, you only have to state continuity for IVT, but we had to talk about differentiability since it didn't just say continuous. All right, so you end up basically saying them both. Oh, well, we don't know that A of C is necessarily. Does that make sense? So it's still V, because we're talking about the function that we have. And then the rate of change of that function will give us A. That's a good question. Okay. Everybody else okay? We good? All right, so then we need a little bit more work here. On both of these, you want to find what the endpoints are. So we're going to want V of 0 and V of 9. So far our work looks pretty much the same, right? So V of 0 is 5. V of 9 is -4. Agree with that? So same thing over here. V of 0, V of 9. It's 5 and -4. Now, what we want here, we have the V's. I want to know, is there a time where V of C is -1? So is -1 between these two numbers? Okay, so I need to say that somehow. I can say it with an interval type of thing, or I can literally just say -1 is between -4 and 5, or 5 and -4. It doesn't even matter. But in my brain, I always have to do least to greatest. Okay? Because we're talking about V's, we have V's here. Here, this is talking about A of C, right? So I found that. What I need to find is the average rate of change. So V prime of C, right, which is equal to A of C, we would see if that equals V of 9 minus V of 0 over 9 minus 0. What is V of 9? -4. So this is -4 minus 5 over 9, right? And then that gives me -1. Okay, everybody okay with that? So do you see how most of the work and even some of this, and it's, even though you only have to be continuous here, if you say it's continuous and differentiable, like if you're not sure, say too much. That's fine. If you also say that, if it's true, it doesn't hurt anything. But then we have our work and stuff, but we have to have a conclusion. Okay? And so these stems kind of help us out here. Since V, or V of t is differentiable, therefore continuous, because really all we have to have is continuous, but the way we know is because it's differentiable, okay? Because it's differentiable, therefore continuous on 0 to 9, okay? So we're stating what has to be true. It has to be continuous. The IVT guarantees that, oh, and look, it was even spelled down here. And I didn't even type that one. Guarantees that, now, let's just go back to our question right here. So, and I can't scroll and look at it, but I'm getting these words straight from that question. There guarantees that there is a time C for, and you could do interval notation here, but I'm just, again, getting it directly from the question. It doesn't matter either way. Such that V of C is equal to -1. Okay? You have to have said somewhere in your work that -1 is between -4 and 5. You can put it in your conclusion if you want to. It's kind of how I do it sometimes. I'm not saying it has to be written exactly like this. Most of this stuff doesn't have to be written exactly like this, but you have to say all the right stuff. Okay? We good on that? Now, again, the only reason we said differentiable here is because we had to in order for it to be continuous. When we come over here, when we're using MVT, since V of t is differentiable on 0 to 9, and continuous on 0 to 9. Okay, so it's differentiable and continuous for sure. Then we have MVT. See if you can finish this up. Guarantees that there is a time. Where are you getting your words from? The question. What questions do you have? So if the writing out of the explanation is confusing to you, don't let it be, because you have work. Then you're just saying that whatever the condition has to be, and then you're basically just rewriting the answer, or rewriting the question. And if you do all this, because I think when we did IVT, we did it and then said, since this is true, then this is true, and then by IVT, that's fine too. Like, it's okay if it comes at the end. It doesn't matter. We all good? Okay. So let's flip this over. I want you to read the question and decide, first of all, if it is IVT or MVT, and be able to defend your choice. Okay, so when I look at this, I'm going to think, okay, it's like, is there a time? So to me, that sounds like it's going to be either IVT or MVT. The information I have is g of x. It is asking me about the rate of change of g of x. So what would this be? MVT, okay? Right, MVT. And then we can do our work. We want to find this, right? We want to find the endpoints from here. So g of 0 is -2. G of 6 is 10. Okay? Everybody good with all that? All right, so since it's MVT and this is a rate of change, I need to find the rate of change. Right, so I can do g of 6 minus g of 0 over 6 minus 0. And that gives me negative, no it doesn't, gives me 10 minus a -2 over 6. What does that give me? 2. All right, so are we good with this? Okay, so now we can say, since, there's different ways you can say it, okay? And sometimes I say since, and then sometimes it's because, but this is what made the most sense out of my brain this time. So, since, now what has to be true for this to be continuous and differentiable? Is it both? Yes, okay. So we've got differentiable right here. It tells us that. So we can say since g is differentiable, and it says differentiable for all values of x, for all values of x, g is continuous on 0 to 6, okay? It's also continuous on all values of x, but we only really care about that part, so that's good enough right there, okay? And then we can say that, therefore, therefore, there is a times C on 0, such that G prime of C equals 2. Okay, and then this right here, and here's what they're looking for on these types of things. No matter how easy the slope is, I don't care if you can look at it and you know the slope is 2. You have to show that you have some sort of difference quotient here. Okay, you have to show that you did it, right? So that's why I would write this step every time and then this step every time and then your answer. Okay, because if you don't show that, it doesn't matter how much you know. Okay, how are we doing? We okay? Ask me a question. All right. So let's read example 2. So read it to yourself. Decide if you think if it's IVT or MVT. What do we think? IVT, okay, so it has an F prime, but just because it's F prime does not mean that it's MVT. F prime matches the table. So can you guarantee tells me it's one of the two most likely. And then because I'm talking about something that's missing in here, this is IVT. Okay. We good with that? So I'm going to start off the same way by finding the endpoints here. So I want F prime of 2 and F prime of 15. F prime of 2 is 1, 15 is 6. So I found these. What do I have to say before I can draw a conclusion? 5 is between 1 and 6. So I can say 5 is between 1 and 6. Then I can say, now, if it's IVT, what has to be met first? What condition? Continuous. All right, so it's still going to sound pretty much like the same up here, though, because it's talking about differentiable. So I can say since F prime is differentiable, and let me just show you something else. Even though it says for all values of x, we don't really care about all values of x. You could put from 2 to 15 on an open interval. That's fine. Okay, so since F prime is differentiable on 2 to 15 or for all values of x, that's fine. F prime is continuous on 2 to 15. Therefore, what? We can, what? Guarantee a time k on 2 to 15 such that F prime of k equals 5. Then by IVT, and instead of we can guarantee, I could have said IVT guarantees. It's the same thing. I think there's also some discussion about whether or not you actually, as long as you have all the conditions, if you don't even put IVT, I think it's still fine, but we might as well put it so we don't mess it up. All right, how are we doing? Good? All right, try example 3 on your own, 100%. Figure out what it is. Make sure your table agrees so we don't go down the wrong road. What is wrong with me? I hope I used the right thing. Do y'all agree? Is it okay if yours doesn't look exactly like mine? Absolutely. But we didn't what? That's okay. That's probably fine. So what did you write? Okay, well, let me see. Like after the therefore, there is a time. Okay, I think that's fine. I just went ahead and used the whole question. You know, just might as well. So you just started. There is a time here. Okay. But if you don't have something to copy, like a different one to copy from, and you didn't put there is a time or whatever, I mean, it's fine. But if you're not sure what to say, just use that question. Okay. Yes. What questions you got? We good? Awesome. Guess what I have for you? Another piece of paper. Yes. You're going to do another one. Oh, I'm sorry. We're all not done. I didn't mean to rush you. Are you okay?
Yeah.
I just
put double prime C equals 0 IVT.
For some, okay, yeah. Yeah, you have to make sure you put the interval. Okay, got it. Good, good. So this will also go on 51. Language. Okay, so read example 4, and then read A and B. And tell me, are they the exact same thing? No. Okay. All right, so A says, what is the fewest number of times that h of x equals 0 in the interval from 1 to 9? Give a reason for your answer. Okay, so first of all, tell me, is this, would A be IVT or MVT? What do you think? IVT, because we're talking about missing stuff in the table, right? So we know that A is IVT, okay? So what do you think B would be? MVT, because it's talking about A, right? Okay, so we will get there. Okay, so let's go back to A. So what is the fewest number of times h of x equals 0 on the interval from 1 to 9? Well, without doing all the stuff that we have to do, we can look at these, even like this one over here, before we did anything, is there a time where f prime of k has to equal 5? Well, yeah, 5 has to, it can equal 5 here somewhere. It's also going to equal 5 here somewhere and here somewhere, right? Because if it's continuous, we have to pass through those numbers. So there is a time, but there's actually at least 3 times. There could be more because we don't have a lot of data, right? So we can figure that out before we ever start, but then we have to have some proof here. So looking at the table, how many times does the table show you that h of x equals 0? Twice. So it literally shows you right here, and then it also could be here, right? Would you agree with that? Okay. So then when we talk about this, if we just use from 1 to 9, then that's going to tell me I have at least 1, but I'm going to have to talk about from 2 to 9 and from 1 to 2. Does that make sense to you? I got to show those. So I need to basically show all of these and say, all right, well, I can have h of 1 equals -2, and h of 2 equals 8. All right? Then I can say 0 is between -2 and 8. Okay? Then I can also just literally say that I don't even necessarily need to use this interval. I can just say that h of 6 equals 0, since they flat out gave it to me. Okay? Like I could use an interval and say that, but I can just say it right there. You with me on that? Okay. So because I'm going to talk about the whole interval, I would like for the whole thing has to be just continuous or continuous and differentiable? Just continuous. But can I only say continuous? No, because it doesn't flat out say continuous. And twice differentiable, do you know what that means? You should get differentiated twice, yeah. Okay, so I can say that h is, differentiable on 1 to 9. So h is continuous on 1 to 9. Okay? That way I don't have to say it multiple times. Now, I said this differently than I did on the page before. So I think on the page before I said, since h is differentiable, and whatever. Okay? And h is looks like his, but it's my bad handwriting, and it's okay. So we've said that it's continuous, which is what we have to say. And then we have shown that these two things are true here, right? We have this and we have this. Then we can say, therefore, there are at least 2 times, or I could say the fewest number of times is 2. That's fine. That would be copying the question like I've been telling you to do. But there are at least 2 times what? H of x equals 0. H of x equals 0 on 1 to 9. By what? IVT. And when you have this stuff written, I mean, we already wrote it here kind of for ourselves. You've already kind of said that it's IVT. I think that's another reason why it's not that big of a deal if you leave it off. But this stuff over here, this is part of your answer and part of your work. Okay, so make sure that you're actually saying those things, even though it's clearly obvious to you, you have to write it down. Okay, we good on that? What questions you got? Okay, we're going to stop here for today.